Okay, percent window. Okay, and then we're going to go. Okay, so I'm just going to read this to you, all right? There once was a great Native American who became famous for his problem solving in geometry. But not really, it's just a silly story. As you may know, in many tribes, Native Americans are given names that represent either their personality or an important event that defines them. The young man that we are speaking about was a very smart boy, but he had a very short temper. When things did not go his way, he would carry on, throwing, kicking, and swearing. One day in geometry class, he grew so frustrated with a triangle proof that he had a huge tantrum and kicked a huge rock. In doing so, he broke his big toe. As soon as he broke his toe, he ran to the lake to soak his toe. While there, he began to reflect on the triangle problem. His sister came along to ask what he was doing, and he said, "I need to soak a toe." That's when it hit him. I need to soak a toe. So-ka-toa. This helped him remember the relationships between the sides and angles in his triangle problem. When he returned home and explained his new idea, a wise teacher in the tribe suggested they name him for the event that made him a better problem solver. That moment when he broke his toe and ran to soak it. So-ka-toa. So this is called the legend of So-ka-toa. So remember, it's just a silly story, but it's designed to try and help you remember So-ka-toa. All right. So can you see my face again? Okay, good. So what we're going to be oh, I guess you also see all my fabric in my craft room there. Sorry. I've been working on quilting and stuff. Okay. So we're going to start up our notes on trigonometry. All right. And I've got them set and ready to go. So yeah.
Do you make quilt? Do you make quilt?
Do I make what kind of quilts? At the high school?
Yeah.
Do I make quilts at the high school? You mean in class?
No. Oh, in the you. If they
No, if they ask me to, no. I don't have a lot of time, so no, I don't. But what I do is, well, just sew a quilt every now and then to have a new bedspread in our house. What did you say?
What do the math?
Let's do the math. I agree. Okay, let's do our math. All right. So, yeah, it's getting late. Let's get our math done, for goodness sakes. Okay. First up, we need to talk about reducing fractions. And also we need to understand how to solve proportions. And I know you're good on proportions, but we're going to go over proportions that look weird. So first thing, if you have a fraction like 2/3 and you want to represent it as a decimal, do you know that you can just do 2 divided by 3 on a calculator to get it to be a decimal? So you can do the numerator divided by the denominator. So 2 divided by 3 is 0.6 repeating, right? Okay. So since it says, if it says to round these to the nearest hundredth, do you remember that the hundredths place is the second one after the decimal? Because here's your ones place where the 0 is. Then the decimal, Then this is the 10th place, and that's the hundredths.
Yeah.
So if we want to round to that, it would be 0.67, right? Oh, let me get my pen. This is not the right pen. Oh, excuse me. Now we're rounding. So when you round something, you should do your squiggling equals to show that you have rounded it. So that's saying it's approximately equal to. All right, number 2. 7/24. 7 divided by 24 is 0.29, and I'm going to leave it at a 9 because the next number is 1. So approximately 0.29. All right, now this one, this looks like the kinds of problems that we do cross products on, only not yet. Here's how you make it into a cross product problem. You can.
I might know.
Oh, what do you think I should do?
The 0.801.
That is perfect. Good job. Because whenever you want to make a fraction, you put it over 1. Good job. So if we want to do the cross products, now we're going to have this times this equals that times that, right? So that gives us 0.8x equals, and 1 times 5.8 is just 5.8.
No one.
Yep. So now I have to do 5.8 divided by 0.8. $7.25. So x equals 7.25. And I can plug that in and see if it makes sense. So if this was 7.25 right here, 0.8 is nearly 1, right? 0.8 is nearly a whole number 1. 5.8 is close to 7.25. So that does make sense, doesn't it?
Yeah.
All right, let's do the same thing with number 4. Put it over 1 and crisscross. So you get 1x equals, and we need to do 0.95 times 8.5. 8.075. 8.075. Well, if you divide by 1, it's not going to change it. So I just wrote over the 1 like it wasn't there. Okay, so if I had an 8.075 right here, would that make sense? So this number is a little bit less than that number. And this number. So yeah, it's a good answer, right? Okay, so we're good on our bell work. We did our skill review. So let's move on. We're going to talk about the trig ratios now. Oops, wrong page. Here we go. This page. So these notes are split up into 2 days. So are you going to be able to meet with me on Wednesday to talk about the second page? I guess we can figure that out later. So our learning target is we will use trig ratios. Trig is short. It's an abbreviation. It stands for trigonometric. We will use trig ratios to determine side lengths in right triangles. So that's our thing. Today we're finding side lengths in a right triangle. So you'll be missing one side length. The first thing it says, the sine of an acute angle. So this is going to be opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. So each one of these is setting up a ratio of 2 side lengths. Okay?
Yeah.
So let's take this right triangle here and let's think about it. First thing I'm going to do, this is going to seem kind of weird. This letter here it's like a 0 with a hyphen in the middle. That is a Greek letter theta. The way you spell that is theta, theta. Okay? So that Greek letter, theta, is what they always use in trigonometry to represent an unknown angle. Kind of like using x, when you solve an equation, but instead they use this to represent an unknown angle. So, theta. So this theta, is one of the 2 acute angles in your triangle. Then you have your right angle, okay?
Hey, Chloe, let you at me. I can play that.
Oh, that you can't say the theta sound because of the TH. All right. Yeah, that's okay. That's okay if you do X. There's a lot of people who still use X. So if you see this symbol, pretend it's an X, okay? You just have to remember that it's not a number. It's like a variable. So we'll just call them all X's then. Okay? All right. So anyway, across from the unknown angle is going to be called the opposite side. So this side over here is the opposite. Okay, do you remember, I'm not sure if I said this to you before, but you can pretend like from the angle, like somebody is holding a flashlight and they're shining the light and it hits the wall that is opposite from the angle, okay?
Yeah.
Okay. Now, this side here, this side is opposite from the right angle.
Nice.
Yeah, the 90-degree angle. You know the name of that, don't you? That side there, what's it called? It's not the opposite. So the only other 2 sides left are adjacent and hypotenuse. It's hypotenuse. Hypotenuse, okay? And then the adjacent is this one. Oops, adjacent. So adjacent really just means next to, but anyway, the way I always think of it is, there's my opposite side where the flashlight shines on the wall, okay? And then here, I'm even going to use a highlighter to show it. So it's like you have your flashlight shining on the wall across. There's your opposite side, okay? Now, you should remember that a hypotenuse is always opposite from the 90. So here's the 90. There's the hypotenuse. And then I just think of the adjacent as being the one that's left over after you label those 2 first sides. So I usually label the opposite side with an O or an OPP. Then hypotenuse gets HYP or just H. And then adjacent gets ADJ as labels, okay? So let's fill this all in right here. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Now, here's how you're going to remember these things. Do you remember me telling you the story about the Native American guy? Do you remember the word that was at the top of that page? What was his name? So, you don't remember? He had to go to the river to soak his toe. So his name was Soka-toa. So his toe. So ka toa. So here's the so, S-O-H. Ka, C-A-H. Toa, T-O-A. These are all the first letters in what I just set up. So is sine opposite hypotenuse. Ka stands for cosine adjacent hypotenuse.
Oh.
Tangent opposite adjacent. Okay? It takes a lot of getting used to because even these are little abbreviations. That looks like the word sin, but it's an abbreviation for the word sine, S-I-N-E. See it up here in the vocabulary, S-I-N-E. Then cosine is abbreviated C-O-S. And when you look at it, the buttons on a calculator, that's what the button will say, C-O-S. But that's an abbreviation for this word, cosine. And then tangent is spelled out this way, tangent. But the way it looks on the calculator button is just, it looks like the word tan. So it looks like sin, cos, tan. But we don't say sin, cos, tan. We say sine, cosine, tangent. Okay?
Hey, could you write out the word? That way I don't say the wrong word.
So you mean the words that this, so you mean instead of writing it this way, write out the whole word? I understand. Okay.
That way I don't say sin.
Yep, I understand. I can do that. So let's look at the first problem here. It says, represent sine of J, cosine of J, and tangent of J as a fraction and a decimal. So angle J is right there. Do you see the J? Probably zoom in because this is pretty small. Is that better?
Yeah.
Okay, now, first thing you have to do to be able to write those ratios, let's write out what it is. The sine is the opposite over the hypotenuse. So it equals opposite over hypotenuse. Well, if we want to write that problem out, it's really just a fraction. But anyway, if we want to figure out what numbers go for the opposite and the hypotenuse, it's a good idea to just label your triangle before you do anything. So you have to start at angle J because that's what this problem is about, angle J. Go to the triangle, find angle J, and then start figuring it out. Starting at angle J, the flashlight is shining here on 60. So that's my opposite side, the 60. And then if I start at my 90-degree angle and I go across to the opposite from that. Exactly, because that's my hypotenuse. Okay. Now they said they want me to write it as a fraction and as a decimal. So we're going to do like what we did in the bell work. We're going to divide it. 60 divided by 61 gives us 0.98 when we round it to the nearest hundredths. Approximately 0.98. Okay.
But in.
We'll box it, sure. So that is the sine. They also want the cosine and the tangent. Now, I want to remind you that these are called trig ratios, and all they are is a ratio of two side lengths in your triangle. And you might be wondering, why do we need to know these? These are like the fingerprints of an angle.
Yeah.
And if you know these numbers for an angle, they can identify what angle it is. You can find out how many degrees the angle is, okay? So I'll probably do something with you in a few moments if we have time to show you kind of how they know this. But let's finish this part first. So the next one is cosine. And because I don't have a lot of room there, I'm going to switch colors of ink to try and make it easier to read. So cosine equals adjacent, here's the toolbox, adjacent over hypotenuse. So I'm going to write ADJ to abbreviate adjacent. Oh, I guess I could spell that out. Adjacent over hypotenuse. Okay.
A over A.
Okay. So now let's go to our triangle. Now, I never put letters on there, but I started at J and went to the 60. That's my O for opposite. I'm starting at 90 and going there. That's my H for hypotenuse. So the last side that doesn't have a label, this is the JL. It has an A for adjacent on it, okay?
Yeah.
So my A over H is going to be this side length over 61. Now there's a little problem because I don't know how long that side is, do I? Do you know what? What do we have to do?
No.
Solve for it, yeah. Guess what you can do with any right triangle when you want to know what one side is? Pythagorean Theorem, a squared plus b squared equals c squared.
Yeah.
So we're going to do, for this triangle, to solve for, oops, I'm sorry, I covered it up. Solve for this missing side right here. I can do a squared plus b squared equals c squared. So I have to do 60 squared plus this side squared equals 61 squared. Goodness. So okay, so I'm writing it like that. So 60 squared is like 6 times 6 with 2 zeros on the end. That's 3,600. But 61 squared, I could do it in my head, but it's going to take me longer than the calculator. So 61 times 61 is 3,721. Now minus 3,600. X squared equals 121. Do you know? Yep, square root. Do you know what number times itself gives you 121? Oops. 11.
11.
11 is the answer. So the missing side here is an 11. Oops. So now tell me what to write for A over H. $11 over what?
Yeah, 1.
Good job. And then I can do a
No.
0.18. Approximately 0.18. Now I ran out of room. Oh, box it? Okay. I ran out of room here for the tangent, so I'm going to use that other piece of paper to write the tangent, okay? So tangent is the TOA up here in SOHCAHTOA. Tangent is opposite over adjacent. Tangent equals opposite over adjacent. Do what?
I never did it before. I never did it before.
You never did this before? Yeah, this is new. So tangent is going to be opposite over adjacent. So that's going to be, uh-oh, this got blurry. The opposite is the 60 and the adjacent is the 11. So we have to put, yep, we have to do that. 5.45. Approximately 5.45. All right, so box the answer. There I go. All good? So now we're going.
I was in the right now.
What did you say?
What did you write down right now?
What did I write down where? Right here?
Yeah.
Oh, I was writing tangent. Tangent of X. Sorry.
Okay.
Of X. Okay, we're going to work just 2 more problems and then we'll be done for the night, okay? So now we're going to use that to solve a problem. So you can see an angle right here that's 30 degrees. You can see this side length is 300 here, and they want us to solve for this height. So it's basically like a building is what it looks like in the picture. And it's like the distance along the ground is 300. Okay, so if you go and label your triangle with your O and H and A for opposite, hypotenuse, and adjacent, you're going to have to start at this 30 and walk it through the triangle to get to the opposite side with the flashlight. So there's the opposite, right? So this is the opposite side. I'm going to write OPP for opposite. Then if I start, isn't this where the 90 is? And if I walk it through the opposite of that, I get hypotenuse. And then the side that's left over is called what? Good, adjacent. So after you do a bunch of these problems, people just start using like O for opposite, H for hypotenuse, and A for adjacent because they get tired of writing. But for right now, it's okay that I did it that way. So if you notice, only one side has a length that you know, and then this side has an X on it. I kind of wrote over it, but can you see the X right there? So the sides that are involved in solving this problem are the 300 and the X. The side length here for the hypotenuse doesn't matter. It's not part of your answer, so you don't need it to solve the problem. So the only facts you know are opposite and adjacent are involved in this problem, okay? Now we're going to scoot this back to your toolbox. Do you remember me calling it your toolbox earlier? You might have been thinking, like, why is she calling that my toolbox? But SOHCAHTOA is your toolbox. Each one of them is a tool that helps you solve problems, okay? This ratio uses those two sides, opposite and hypotenuse. This ratio uses adjacent and hypotenuse. That ratio uses opposite and adjacent. So each one uses a unique pair of sides. Which tool do we want to use if this problem is involved with opposite and adjacent? Which tool uses opposite and adjacent?
O, A.
Good. O and A. So that's the tangent one. So first thing we do is we kind of write out that to help us know how to do it. So the T stands for tangent. We're going to put tangent X, because, oh, just not X, I'm sorry, of the angle, tangent of 30. I didn't mean to do that. Tangent of 30 equals, and you have to put O over A.
O.
So your O is the X. Good job. Okay, so you have, this is your equation. The tangent of 30 equals, oops, that's supposed to say 300, silly me. The tangent of 30 equals X over 3. That's your whole equation right there, okay? Now, I'm going to get my calculator going and I'm going to do the scientific part on it, okay? So you can find out the tangent by just looking it up in here. The tangent of 30 degrees, I'm going to type 30 and press the tangent button. See the tan, oops, I pushed the wrong thing. Do you see the TAN right there by my finger? That's tangent. So the tangent of 30 degrees is 0.577, okay? I'm going to put that in place of this word tangent 30. 0.577 equals X over 300. Now, what do I do to solve that? Almost. I can put this over 1 and do a cross product. Right?
Yeah.
Okay. So then I end up with 1x. So just x. And then I have to do 0.577 times 300. Well, I still have that number in the calculator before it was rounded, so I'm going to use that. Times 300 equals 173.205. So if I want to round it to the nearest hundredths place, it's going to be 173.21. About, so I'm going to put approximately 173.21. And see the units they have right there are feet. So I'm going to put feet on my answer. Okay? You ready to do another one?
Yeah.
Okay.
What about the number 4?
What about the number 4? You mean the one that was underneath the one we just did? That one right there?
Yeah.
You want to do that one. Okay. So it says a sailboat views a seaplane at an angle of elevation of 25 degrees. There's the 25-degree angle. Determine how high the plane is above the water. So that's labeled with the X. If the distance between them is 75 yards. So there's the 75. So let's label the triangle with respect to the 25-degree angle. So starting at the 25-degree angle, we got to shine our flashlight on the opposite side and put an O for opposite.
Oh.
Then we've got to go to our 90-degree angle and shine a light on the other side and put what letter? H. And then that leaves A. Okay? So now we have to choose a tool. So the sides that have labels are, we have a label on this side here and a label on that side there, right? So that's the O and A again. So it's the same ratio. It's tangent, because when I go to the toolbox, doesn't tangent use O and A?
Yeah.
So I'm going to go tangent of my angle. So the 25 degrees goes next. Tangent of 25 degrees equals O over A is over what?
No, come on.
Good. So now I have to go look up the value for tangent of 25 in my calculator. So I'm going to type 25 tangent, and it tells me the value is it was 0.466. And that equals x over 75. Now what? Good job. And then cross product. So that's, and now I need my calculator. So I have to do, let me get that number back. So that number times 75. 34.973. So about 34.97 yards.
And we plug it in.
Sure. So let's put 34 here, 34.97. So that's almost 35, right? Does 35 make sense here when this is a shallow angle, small angle, and it's making this side more. So it looks like a good answer, doesn't it? Okay, so both of those problems used tangent, okay? And so does that other one, but I'm looking for one that doesn't. So give me one moment.
But that of the no.
Yeah, this is the other part of the notes. This is the next page, but it has one problem. It has one problem in it that we can do now, but the problem with it is that it's another tangent problem. These are all tangent. The way I know it's tangent is that's the opposite and that's the adjacent. So we need something where the hypotenuse is labeled. So let me just pull a problem and I'm going to shine it. I'm going to put it on the screen in a moment and then let you look at it together with me. And then we'll just work it on scrap paper. So let me show you first. Okay, now I have to click print. So let me do that.
Do you know what they will my clip be?
No, I don't know yet, but we can talk about that in just a second. No problem. Okay, so can you see these problems on the paper? So the first problem's there, they're asking us to write the ratios, but these are telling you to use the ratios to solve for x, okay?
Yeah.
So we need to do one of those. So let's do this one, number 6 with the 61 on it. Do you see it? So I'm just going to copy that one onto scrap paper and do that one problem with you. That'll be our last problem tonight. Now, do you see how look at the 61 degrees and just with your eyes, trace that to the opposite side. The opposite side doesn't have a label, does it?
No.
So this one is not going to use opposite. Okay, this one is going to use hypotenuse and adjacent, but not opposite. All right, let me bring you back to my camera. Okay, so there's that same triangle. So if I shine my light from the angle, there's my opposite. So that's my O. If I start at my 90, there's my hypotenuse. So that's my H. Then this leftover side is the A. Okay. So I have labels on H and A. So let's look at our trigonometry toolbox real quick. Which one uses H and A? Yep, the C. And C is for cosine, okay? So it looks like this. Let me zoom out a tiny bit. It looks like this. C-A-H, right? You remember seeing that? It looked like this, C-A-H on the toolbox.
Yeah.
So we're going to write cosine, then our angle. So we need to put what for the angle? 61 equals, and then we have to put A over H. Can you tell me what to put?
No.
Good job. So now, what do I have to do?
I don't know what.
Get the calculator. You're right. I need the cosine of 61 degrees. And the calculator is going to help me look up that number because this is one of the fingerprints for the angle. Cosine of 61 is 0.4848. So I'm going to round that just to 3 spaces. So that would be 0.485. Good job. Cross product. So do you see how this one's different when I go to do my cross product, isn't it?
9 equals 0.0.
Nice work. Now what do I do? Good. Okay, so I need my calculator and I'm going to do 0.09 divided by 0.485. Okay, so 9 divided by 0, oops, there. 9 divided by, oh goodness, 9 divided by 0.485. There we go. 18.557. So like 18.56. X is approximately 18.56. Box it in. So did you notice how when I looked up the number on the calculator, I did 3 spaces. I went to the thousandths place.
Yeah.
But then for my final answer, I only went 2 spaces to the hundredths place. That is something that people will do, is if they know that they're trying to get to the hundredths place for their final answer, they will carry an extra decimal place through the problem because that helps it to be more precise, okay?
Yeah.
Because if you round every answer throughout the problem, you will end up with it's what they call a rounding error because you're rounding everything and making it different throughout. But if you carry an extra decimal place, it helps prevent some of that rounding error. Okay, so that's our last problem. Let me go ahead and hit stop. Pretty good stuff, huh?
Well,
I'm waiting to see what happens.
now
There it goes. Okay. And how we know what the trig ratios are for an angle. Okay. Do you remember me calling them the fingerprints of the angles?
boy.
It's blurry.
Yeah.
I wonder if it has something to do with internet speed. All right, well, let me put this camera on the paper and you tell me if you can see it better. Okay, so let me get a pen and my ruler. Okay, I'm going to draw a triangle. You let me know if it stays blurry.
Yeah.
It's still blurry?
Yeah.
I think it has to do with the internet speed. So I don't know what to do to change that because on my screen, it does not look blurry at all. It looks really clear. Let's wait a moment and see if it clears up. I'm going to see if it fixes itself.
No, it's not me. Come back.
Okay, is it still really bad?
Yeah.
Okay, I'm going to hang up. You can stay on, but I'm going to hang up and open it up again, okay?
No.
It's better?
Yeah.
Okay, good. Now I'm just trying to get, whoops. Okay, there we go. So all right, so what I did was I drew a series of triangles. Is similar to the one here, which is similar to the one here, because all of these lines are parallel. So what it did, it formed a series of similar triangles that all are congruent. They're all corresponding angles. So I drew a bunch of triangles that are similar, which means they have the same angles, causing them to have the same shape, but a different size. Now what I'm going to do is I'm going to actually measure with a ruler how long this is. So right there, I'm measuring that. It is 1 7/8. So that right there is 1.875 is 1 7/8. I think they're probably all going to be that, but I'm going to double check because I used the ruler and I kept them all the same distance apart.
I can't.
Oh, this next one's not. You probably can't read my ruler, right? But that's okay. I can tell you what it says. So this is 1 5/8. 1.625. This one is also 1 5/8, 1.625. And then this one, probably also 1.625. Oops, there we go. Now I'm going to measure along the bottom. This is
Whoa.
1.5. Well, 1 point. Okay. So these are all 1.375. All right, now. Is it still blurry?
Why is not? Why is not? Small.
It's what? It's like it's what?
Not small.
I don't understand.
I can see it okay now.
You can see it now? Okay, good. I'm going to, okay. So what we're going to do is we are going to write ratios. Okay, I have to do all the height. This is 1 inch. This is 1, and I'm going to call that 1.9. And then this is 2.
Where do you
Point 8 about. Well, I have it. I'm just trying to measure something. I've gotten to measure these, okay? Now here's what we're going to do. We are going to write tangent of this angle right here by my finger, okay? But we're going to write them for each of the triangles. So I'm going to color the triangles different colors. So this smallest one is going to be this orange one. Then the next one is going to be blue. Then the next one is going to be green. And then the next one, I think I got my purple marker here. Okay, so I move the paper. I think that what's going on, I think bandwidth must be really slow. And so when I'm moving the paper, it's causing it to get blurry when I move the paper. So is it okay now, Connor? Did it stop being blurry?
Yeah.
Ratios. So we're going to do sine and cosine and tangent. Okay. So I'll start with sine. I'm going to write that up here. So remember SOHCAHTOA, right? SOHCAHTOA. So that stands for sine is opposite over hypotenuse with an X. So the sine of X equals. Can I do what?
No boy.
Can I fix it?
Yeah.
I don't know. Is it blurry right now?
No, but keep going in and out. It keep going.
I think it's, well, I understand what you're saying, but I think it's probably the speed of the Wi-Fi that's causing it. I don't know I don't know something I can do about it.
Okay.
So we'll try to do the best we can, and every time you can't read something, just let me know, okay?
Okay.
Okay, so right now we're going to write ratios of opposite over hypotenuse. So for this whole series of triangles, vertical lines are all my H's. Okay, those are all right. And this one's 1.9 and 2.8, 3.75. Now, wait, did I say hypotenuses? I meant to say opposites. Goodness. The hypotenuse is across from the right angle. So the right angles are here. So the hypotenuses are here, and then all of this, okay? So we're going to make some ratios with the opposite over the hypotenuse. So first number I'm going to use is these vertical ones because those are the opposites. So this is my first O. This is a 1, and I'm going to put it over. Now that's the orange one. Next, we're going to do the blue one. So this measurement here, if I add up 1 point side there, that would be, let me grab a calculator. Is everything okay, Connor?
Yeah.
Okay. That's 3.5. So for the blue one, I'm going to write 1.9 over 3.5. And that's the blue one. For the green one, I have to add in this 1.625 with the 3.5. So that's going to be 5.125. So that one will be 2.8 over 5.125. And that's the green one. And then the last one is this purple one. So if I add all of that together, I have 6.750. Wait, I just added that wrong. Oh, no, I'm looking at the wrong number. Okay. 625 and 125 is 750. Yeah, that's right. Okay. Sorry, I was just double checking. So the purple one is 3.75 over 6.75. Purple. Okay. So now I'm going to use the calculator and divide that and see what number I get, okay? Calculator. There we go. Okay, so I'm going to do 1.1 divided by 1.875. That gives me 0.53 repeating. So the answers I get, since I don't have a whole lot of room, not a lot of room, but I'll try. So the first one I got is 0.53. So 0.53 with a bar. That's the orange one. The next one, 1.9 divided by 3.5. That gives me 0.54. That's the blue one.
Why don't you do it with your phone?
With my what? With my phone? I don't have my phone in this room right now. Divided by 5.125. And that gives me 0.54. And that's the green one. And this last one, 3.75 divided by 6.75. Something happened with the computer. 3.75 divided by 6.75. Huh. Something's not right. Oh, that's what's wrong. 3.75 divided by 6.75. That worked. That one's 0.55. Okay, so all right. Now, look at these numbers. 0.533335, 0.54, 0.54, 0.55. These are all pretty close to the same number, aren't they?
Yeah.
That's because they really are the same number. It's just that when I measured everything, I was using a ruler and I was using my eyeballs and I wasn't very precise. Okay. But if I was very precise, they would all come out to be the exact same number. Now there is, since they're all coming out the same, that makes sense because you're setting up ratios on triangles that are similar to each other.
Yeah.
And when you set up ratios on similar sides and you divide them down, it's like you're reducing the same fraction, kind of like, I mean, it's not the exact same numbers, but it's kind of like if you had 1/2 and 3/6 and 4/8 and so forth, right? They all reduce to have the same value. They just look different, but they have the same value. So this blue triangle, because of it being similar to the orange one, it's going to have the same value when you make that ratio of side lengths. The numbers might look larger, but when you reduce the fraction or divide it like what I did, the actual value of the fraction is the same value. Does that make sense the way I'm saying it?
Yeah.
Okay, so no matter how big your triangle is or how small your triangle is, whatever angle this x is, this is the sine value for it. Somewhere around 0.53, 4, or 55 is the sine value for it. And if I change this angle to something else, it will have a different sine value, okay? It will have a different decimal for its sine value. So do you remember me showing you the table of values? And it showed us every angle has its own values for the sine and for the cosine and for the tangent. And why that matters is you can use it to help you solve problems. If you don't know what x is, you can actually, if you don't know this angle, you can find out what it is. Because if you know these values, you can work backwards and find the angle that has those values. So that's why I called it the fingerprints of the angle. It will tell us exactly which angle we're working on if we know the sine or the cosine or the tangent. Okay? All right, so let me go ahead and go grab your practice problems. You remember what we were working on last time, right? Did you have a chance to watch it again?
Yeah. Hey, are we gonna do more? No.
Oh, good. So
Are we
yes, we
ready?
are. In fact, you know what? What?
No.
Nothing? Okay, all right. So I just was looking and thinking to myself, we should probably do one review problem so we can remember what we learned last time. And these are last time's notes. And do you see the blank ones here that we never used? This one up here says represent the sine of angle A, the cosine of angle A, and the tangent of angle A as a fraction and as a decimal. Now, this paper has,
Whoa.
oh, goodness sake.
I hear you.
I'm
No.
going to redraw, restart.
Yeah.
Is that what you said? Restart? Okay. I didn't understand that last thing that you said.
Not you go.
My computer. I don't think it's my computer, but I can. That means I'm going to have to hang up and it'll take me at least 3 minutes, okay? I'll go ahead and do it. And then you're going to hang up too, okay? And then I'll send you another invite. Well, okay, you can actually you can stay in the call if you want, but I'm going to hang up. And then if I'm not back in 5 minutes, check your email, okay?
Oh no! 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 No. No. Hi. Hi. Where are you? Where are you? Where? Where are you? Are you back? No. Hello. Where are you? Hi.
Hi.
I can feel okay.
Well, it's just a paper. Here.
Yeah, okay.
Okay. So we're going to do this one first. Here, let me move things a little bit. Okay, so they went the sine, the cosine, and the tangent of angle A written as a fraction and a decimal. Now what? I don't know why the computer just chimed at me. I hope it's not telling me something important. Okay, so our problem is that there's no room to work this on that paper. So I'm going to copy the triangle over again right here. Okay, so there's the problem. Okay, there's the triangle in the problem. Now, if I want to write all the ratios, I need to know all three sides, but they've only given us two of the sides. So what do you do? A squared plus B squared equals C squared. Yes, that's exactly right. So I'm going to be solving for this, right? So I need to put nothing for A, and then 24 for B, and 25 for C. 24 squared is 576, And 25 squared is 625.
My
And then that's 49.
Now
what? Okay. Okay, so that means that this side here is 7. Oh, look, 7 is shaped a lot like a question mark, isn't it? Okay, so that's a 7. Now, when we write our sine and cosine and tangent, we use those 3 numbers, 7, 24, and 25. Now, this is supposed to be for angle A. It said the sine of angle A and the cosine of angle A and so forth. So starting at angle A, if I go through the interior of the triangle to the opposite side where the light is shining, it's on that side, right? That is the opposite side. Then if I start at my 90-degree angle and I go to the opposite side from the 90-degree angle, what is that side called?
Hi.
Yeah, hypotenuse. Good job. And then this side is called the adjacent. So I just put ADJ because that's the first 3 letters of adjacent. Now remember, this is called SOHCAHTOA. That's just an acronym to remember each thing. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So first one we're doing is sine with O and H. So what do I need to write? Good job. And then for cosine of A, I want adjacent over hypotenuse. Good. And then tangent. So that's going to be O over A, right? Good. So now we're going to work out decimals for those, okay? So I'm going to turn on the calculator. Yes, exactly. Divide. So 7 divided by 25 is 0.28. 24 divided by 25 is 0.96. 7 divided by 24 is 0.29. Okay. So now I have all the decimals for them. Now, do you remember what I said earlier, that you can actually use that to help you find out the number of degrees in the angle? Because these are like fingerprints for the angle, and they identify which angle you're talking about. So I have a trig ratios sheet, and I'm going to open it on my screen and let you see. really quick. Another screen, so that's going to.
Are we gonna do the other part? No. No.
We are. What we're doing right now is something that we will be doing today for the new note. So I want to show it to you. Before we get to it. Okay.
I can't.
I know, it's my fault. Just be patient. For some reason, I can't. I can't find it, so I'll just come back to this later after I find it. Okay. So the next thing we had to do last time was to find the x value here. So this is it. Now the sides that have labels with information that are involved in this problem are that side and that side. So that means this problem uses the hypotenuse and the adjacent. So when we check out our SOHCAHTOA toolbox, which tool uses opposite and, I'm sorry, which tool uses hypotenuse and adjacent?
I know.
It's this one. Right there. So then we put our equal sign. And we have to write x over 125. Now what do I do? I have to get the cosine of 40. So let me grab my calculator.
How would you do?
What did you say?
I didn't do it.
Do you have cosine buttons on your calculator?
Yeah.
So you need to type. What does your calculator look like? See, does it say sine, cosine, tangent buttons like that?
Yeah.
Okay. This is the answer you should get when you type it in. Oh, shoot, where's my pen? There.
One more.
40. And then you have to push the cosine button.
Zero, one, never, zero.
That's right. Okay, so now I wrote that number in the place of cosine 40. And then I put equals x over 125. What do I do now?
One.
Okay. And now we have to do our cross product. Yep. So x equals, and I have to do that number we got for the cosine times 125. And this is what it, so that's approximately 95.76. I'm going to round it to that. And since they had feet on the triangle, that's in feet. And I can figure out, does that make sense for an answer? Is that in the same ballpark as 125? It seems right. It's the number 95 is close to 125.
Yeah.
So it's a good number. Okay. Okay, so let's do what we have for this time. Now we're not going to go too far, but what we have to understand, and the reason why I showed you all the information earlier about the fingerprints, is that if you know the ratio, you can use it to find out the angle. You can use it to work backwards, okay? So, this is supposed to be the second button. I'll explain what this is all about. But here's the most important thing. We're going to use inverse trig ratios. Now, by inverse, it means it helps you to work backwards and find out your angle. Okay? So inverse Trig ratios can be used to locate an angle. This blank is used SOHCAHTOA to help you remember your trig angles. Then this says locate the, this is just the acute angle that you want to solve for. Choose the trig ratio for the given sides. So remember how we're always tool, and then this is substitute the values, and then use the calculator to work it out. So we can remember that sine is opposite over hypotenuse. Cosine, that's the so that's adjacent over hypotenuse. And tangent, that's the TOA, so that's opposite over adjacent. All right, so here on example 1, we know two sides and we can use it to here. Then you have to label your triangle with respect to angle J. So starting at J, this 60 will be the opposite. And then starting at the 90-degree angle, the 61 will be the hypotenuse. And then the last side over here is the adjacent. It starts out being exactly the same. So these two sides that have numbers. Oh, you found the third side? We're not going to need it. So you already worked that out. You're fun. You did. Let me see what you did. Hold on.
No.
Did you?
Because I knew it from the other day.
Oh, you're right. I forgot about that. Okay. Well, we won't need that side. The other day we needed it because we were writing the sine and the cosine and the tangent. And if you're going to write all three ratios, you have to know all three sides. But going to pick the one that uses the two sides that are labeled. So the two sides that have a label are the hypotenuse and the opposite. So when you look at your SOHCAHTOA toolbox, and the hypotenuse. The sine, the cosine, or the tangent. You can just say S or C or T. Which one? Good. So you have to write out sine. And then normally we put the angle next, but we don't know the angle. So we're just going to put the letter J because that's the name of the angle. The sine equals the opposite over the hypotenuse. So that's going to be 60. Exactly. Now you remember I said you could do the inverse today, right? The inverse. So we're going to go to the calculator and we're going to do the inverse. Now, let me clear this out. So we got to get the fraction in there first. 60 divided by 61. 60 divided by 61 equals, okay? I want to know what angle has that ratio. So I'm going to tell the calculator to work backwards and find out the angle that has the ratio. So what I do is See the button that says second? I'm going to push second. And then if I hit sine, see how it looks like sine, the little -1 next to it?
Yeah.
9.6. Now, the only thing is I forgot to write the buttons that I'm pushing on the calculator. So hold on. I should have written something else first. This is the answer, but what I should have written on the paper is this. So, because that's what I did on the calculator. Sine in, this is a symbol for the inverse, this little -1. I did the sine inverse of 60 over 61, and that gave me this angle, 79.6 degrees, so almost 80 degrees. Let's look at our triangle and think, does that make sense for angle J? So let's look at the shape of everything. This is 90. This angle, does it look like it could be 80 degrees? Quite 90?
Yeah.
Yeah, it does. And this one here looks really sharp and skinny, like 10, right? So if this is 80, this must be 10 over here, right? Because these two angles add up to 90. So 10 degrees would be really shallow and small like that. So those answers make sense. All right, let's do another one. Okay, determine the measure of angle B to the nearest degree. So we're going to label this triangle with respect to angle B. Here's angle B, and across from it is the opposite side. Then let's go to the 90. And across from that is the hypotenuse. And then the last side is adjacent. Well, this is sine again, isn't it? Because it's opposite and hypotenuse again. So this is almost the same as the problem we just worked, isn't it?
Yeah.
Because yeah. So we're going to write the sine of angle B equals, can you tell me the opposite over the hypotenuse ratio? Good.
No, what?
So then, yeah, but you know what I'm going to do? That's what I'm going to do on the calculator. But on my paper, I should write this before I use the calculator. Okay. So let me clear it. 24 divided by 20, oops, 24 divided by 25 equals, oh, that's not right, 24 divided by 25. Okay. Now I'm doing second, sine, 73.73. Okay. So B is approximately 73.7 degrees. Let's think about if that makes sense for this triangle. Yeah, it does, because that's a time over there.
Yeah.
So closer to 60. Okay. Then we're going to do 8. The ramp on the back of a moving van is 3 feet high. So I'm already going to start labeling this, okay? Have you ever seen one of these, Connor? Have you seen, sometimes big trucks, they have, what this is, I don't know if you can tell, it's got a little handle on it. So basically, it pulls out of the back end of the truck, and it slides out, and then they drop drop it down to the ground. They load things, boxes and different things on, and then they use what's called a hand truck, and they wheel it off of there. Okay, cool. So I'm going to put 3 feet right here because it says that it's 3 feet high. Okay, so this is the 3 feet right here. And it says it extends to a length of 10 feet. So I'm going to put a right angle here because that's how we measure height, is vertical to the ground. So if it extends to a length of 10 feet, that must be how long the ramp is. So that's this number here, 10 feet. And they want to know what's the angle of the incline. So basically the incline is the angle it makes with the ground. So they want to know this angle right here. Okay. It's obvious. There you go. It's 10 right there. Okay. So now if this is the angle that we're trying to solve for, then the triangle has to be labeled with respect to that angle. Compared to that angle there, if I go through to the opposite side, like I'm shining my light on the opposite side, then this is it right here. And then here's my 90-degree angle. So if I shine my light on the opposite side, that's the 10. So that is the hypotenuse. Because the hypotenuse is always opposite from the 90, right? And then the last side over here, this must be the adjacent side. So now we have to choose a tool from the toolbox, from the SOHCAHTOA. So which tool do we choose? We have a number for the hypotenuse, and we have a number for the opposite. Oh my goodness, we keep using the same tool over and over. What is opposite in hypotenuse? It's sine, right? Yeah. So we're going to do sine of x, because we don't know the angle, equals opposite over hypotenuse. Tell me what to write. Yep. Now I'm going to write sine inverse of 3/10 because that's what I say when I'm looking it up in the calculator. Okay. So 3/10, that's going to be 0.3, right? There's 3/10. Sine inverse is 17.4576, blah, blah, blah. So 17.5, basically, if I round it. So x is approximately 17.5 degrees. Okay? All right. So basically, it's doing the same kinds of equations when you set up the ratio, but instead of solving for the side that's missing, you're solving for the angle that's missing. And when you solve for the angle that's missing, you have to use the inverse function on the calculator to look it up in the calculator. Okay, I'm going to hit stop on the recording.
Where do your mom live at?
Oh, she lives in New Orleans. Have you ever heard of New Orleans? It's about 800 miles from here.
Are you gonna play your RV?
Am I going to take my what?
RV.
Oh, my RV. No. I forgot that you knew I had an RV. No, my husband's not going to go with me this time. I'm going to go on a plane. Okay, which means I have to wear a mask. I mean, I normally wear a mask anyway, but I'll have to wear a mask on the plane, you know? I think I might wear 2 masks on the plane and wash my hands about 30 times. Okay, so let me see. There's a page missing here. There we go. It was just out of order. So this is the first thing. We have to remember what the trig ratios are. So the first thing to know is your toolbox that I've been calling it. Your SOHCAHTOA. So sine is just opposite over hypotenuse. So we're just remembering those things. Cosine is
Hey, over 8.
good. And tangent is
Over 8.
good. All right, underneath that it says writing trig ratios. So this is where you make a fraction from the sides. Sine of angle x. So here's angle x. If I label this triangle with respect to the x, starting at the x and going through the triangle to the opposite side, that would make this the opposite. Starting at the 90, that would make this the hypotenuse. And then the third side is the adjacent. So the sine of x is the O over H, and that is the good job. And I can't reduce that, right? Because there's no number that divides into both 12 and 13. The cosine is A over H, and that is good job. Also, that can't be reduced. And then the tangent of x is O over A. Good. That was a tough one, but you got it. And that can also not be reduced because there's no number that divides into both 12 and 5. Okay. So now, do you see down here that they have the exact same triangle? See, look, 5, 12, 13, 5, 12, 13. But this time, instead of this being x, it's angle z. Okay? So this time we're going to label starting from angle z. We'll label the triangle with respect to angle z. So if I trace it through across from the z, that's my opposite. If I start at the 90 and go across, that's my hypotenuse. And that makes this my adjacent. So I just want to compare that for a moment. They both have the same hypotenuse because the hypotenuse is always across from the 90. But the adjacent and the opposite have switched sides, haven't they?
Yeah.
Okay. So the sine of z is the opposite over the hypotenuse, and that's going to be 5 over 13. The cosine is the adjacent over hypotenuse, so that is 12 over 13. And the tangent is opposite over adjacent, so that is good. No, not 13, 12. Right? Because it's the A, so it's the 12.
No. That one.
Oh, I'm sorry, I misunderstood you.
That one.
Okay, good. So now let's compare things. The sine of x is 12/13. And then down here, the cosine of z is 12/13. See that?
Yeah.
Then the cosine of x is 5/13, and the sine of z is 5/13. And then I'm going to compare these this way. So what's the pattern with the two tangent numbers?
They all flip.
Good job. All right, now let's think about why that's happening. If we focus on the tangent, we're going to completely understand what's happening. Since the opposite and adjacent are the sides that have switched places, then this has to be flipped when you switch the places. That makes sense when you think about it.
Yeah.
And then when we look at the cosine of x and the sine of z, the reason why they are the same number is because the hypotenuse is not changing in your denominator, and the opposite of z must be the same as the adjacent of x. Yeah, the opposite of z is the same thing as the adjacent of x. All right. So there's some weird patterns going on, but anyway, that's how we write our ratios. All right, let's go to the next thing. We do not have to do these because they're not going to be on our test, so I'm going to skip those. Is that your sister?
Yeah.
All right, so this is, see how we have two more pages? We have this page with a total of 5 problems, and then this page with 5 problems, okay? They're both mixed. They both have solving for sides and solving for angles, okay? So we are going to, excuse me, all right. We're going to work on both of these pages. We have 10 problems to do together.
I might be late for my class on Monday.
You might be. We're going to have to see. All right, so let's see. This first problem says that it has an angle that's 34 degrees. Can you see that, or do you want me to zoom it in a little bit? Zoom it. Here. Is that better?
Yeah.
Okay. So you can see the 34, right? So then there's an 8 here and there's an X there. So if I think about what two sides we're talking about, this 8 is across from the 90. So what should I label that? Good job. And then this X is not across from the 34. Across from the 34 is here, right? This is the opposite. So this is the adjacent right here. So our two sides that are involved in this problem are hypotenuse and adjacent. So let's look at our toolbox. Here's our SOHCAHTOA toolbox. Which trig ratio do we want to use to solve this problem? Good job. So that means we're going to write cosine of our angle 34 equals what?
Over 8.
Nice job. Yeah, I'm going to grab the calculator. Oops. It was hot because it was attached to the cord.
I couldn't do it. I couldn't do it.
You can do it? Okay, go ahead.
What number?
You need to type 34. And then you need cosine. It's okay. It's not bothering me at all. Okay, so you did 34 and then you press the cosine, and what did you get? 0.829?
Yeah.
Okay. Give me 3 seconds. All right, so that equals x over 8. Now we put it over 1 and we do our cross product. So can you take the 0.829 and multiply it times 8, please?
No.
652?
No.
Hold on a second.
No.
Okay, let me try. 0.829 times 8. 6.632. I got you now. Like that. Okay. So that equals x. Now we have to decide, does that seem like a good answer? And I think so, because do you see how beside with the x, it has to be shorter than the 8, doesn't it?
Hey, you're worried about
6.632? That's not right? Oh, you mean like this? Is that what you meant?
Yeah.
Yeah, okay. Sorry. And also, they didn't give us like units. They didn't say feet or inches or anything, so we're just going to leave the number. But you see what I was saying about 6.632 is a good number because it should be slightly shorter than the 8, right?
Yeah.
Okay, let's do number 2 then. So for number 2, they're giving us a 36-degree angle, and they've labeled this side here with an X and this side here with a 20. So we need to label the triangle with respect to the angle. Let's start at the 36. And from the 36 through to the opposite side makes this the opposite. From the 90, that makes this the hypotenuse. And then that makes this the adjacent. Okay? So then from our SOHCAHTOA toolbox, let me back up and let you look at the toolbox. There you go. Can you see it? Which one do we want to do, sine, cosine, or tangent?
Oh, 8.
Good. We're going to do over h. So we're going to write sine of 36 equals what? Nice work. Okay, can you get that calculator going again? So it's 36. And then you need to do the sine.
They will flip my 8 7.
0.5877, like that, or is it a 9? Okay.
Do you get it?
This number right here is 7?
No, 5.
Okay, let me double check on my calculator. I was answering a message from another teacher, so I have to, okay. So I need to do 36 sine. 5877. Okay, so we did it right. Okay. So that equals, oh, and that's times the x. Look what happens this time. Well, I'll finish it first. So that equals 20 over x, right? I'm just copying this number in place of the sine 36. Then I'm putting the 1 and the 20 and the x. So now we're ready to do our cross product.
They won't on 5 8 7 equal
All right. Good job. So then the next thing is
the y.
good. So we're going to do 20 divided by 0.5877. Is this what you got, 34.03?
No.
Let me double check. 20 divided by 0.5877. Oh, try it again. I think that's the right answer. Good. Okay, so we do have the same answer. All right. Now, we have to think about whether that makes sense. So that's supposed to go here, which means it would be the hypotenuse. So it would need to be the longest side. So it would need to be bigger than the 20. It is. So that's good. Okay, let's go to the next one. This one we're going to do is going to be the word problem. Let me see, though. Let me see real quick. We've done cosine and we've done sine. We did a bunch of tangent on the examples the other day. All right, well, let's do this word problem. Do you see this this crane? It's hard to get me. I'm trying to fit it on the screen. Hold on. It's getting blurry, I know. I'm trying to fix it. There. How's that? Can you see it?
Yeah.
Okay, let me zoom in a tiny bit. There. That's about as good as it can get. So we have a 45-degree angle. If we mark this with respect to the 45-degree angle, this will be the opposite. Then this will be the hypotenuse. And this will be the adjacent. Okay? So which tool do we want to use from our trigonometry toolbox if we're using SOHCAHTOA? Good job. So that is the T. So that's tangent. So we're going to write tangent, then our angle, which is 45, equals what? Good work. Now, the tangent of 45. So can you type 45 tangent, or do you want me to do it? Can we both do it? You do it and I do it. We both do it and we check each other. We'll see if we get the same answer, okay?
One.
Yeah, 1. That's what I got too. So 1 equals 60 over x. Now what?
One.
Okay. Okay, so 60 equals x. That one was easy. We didn't even have to divide, did we? All right, yes, sir. X equals 60. Box it in. The 60 makes sense on this triangle. That's interesting. So look, this is 60, but we just found out that this is also 60. Why do you think that's happening, Connor? Why do you think that these are both 60s? Is your sister in your room?
Yeah. Oh, my door. Why?
Maui, come on. Maui in here? Do what? Well, you don't need to scream at her like that.
Okay, I do.
Okay, so do you see how this is a 60? But this also came out to be 60?
Plane.
Right, so why do you think that happened?
They are equal.
Yeah, so is there anything else in this triangle that you think should be equal because of that? What is it about a triangle that there's a relationship between the angles and what?
Yeah.
The angle and the side, yeah. So if the two sides are the same, then isn't this an isosceles triangle? And if it's an isosceles, then this angle and that angle are both 45. Yep. All right, so let's go ahead and do some more. You ready? We're going to go to this question. So now we're going to look at problems with missing angles. Missing angles. This is zoomed in pretty far, but that's okay. The triangle is not. You what?
I don't forget over the weekend.
I don't think you will. If you do, we'll just remind you on the day that we're taking the practice quiz. It's no big deal. I don't think you should be worried at all.
I can go back and watch.
That sounds like a plan. You can go back over it and watch the video. So this is a missing angle, all right? So if this angle is missing, we can still label the triangle with respect to that angle that's marked there with the X. So if I start at X and I trace through to this side, what do I call that?
Oh,
Good job. If I start at the 90 and I trace through, what is that? Nice. And then this is adjacent. That's a hard word, isn't it? Adjacent. Yeah. Okay. So I'll say that again. Okay. So then we're going to do. Yeah, you need your toolbox. That's right. SOHCAHTOA. Okay. Good. So we want sine of X equals. Good work. Okay, so now we can't plug in X to the calculator. It won't work that way. So instead, we have to work it backwards and use the inverse. Okay, so we're going to get a decimal for 24/29ths and do the inverse of that. So here we go. Let me do this one because it's a little bit tricky. So.
No, I can do it.
Okay, we'll get a decimal for 24 divided by 29 first. Do 24 divided by 29 and get the decimal. Okay, so what did you get for 24 divided by 29?
8.1.
That's the same thing I got. Good job. Now keep that number in your calculator, and we need to do the sign of that. So you're going to push the sign now.
What?
The one that says SIN. Right there. Oh, I forgot. I told you the wrong thing. I'm sorry. Shoot. I wasn't thinking. I'm sorry. Did you do it yet? Don't do it yet. It needs to be second sign. It needs to be this button that says second. See that one I'm pointing to? You have to push that first, and then it gives you the sign inverse with the -1 on it. That's how you have to do it. So you get this answer.
Negative. I is a negative.
Are you talking about, when you said negative, are you talking about the sign to the -1?
What do I negative?
Oh, you need to push this button that says sine. I'm not sure what kind of calculator you have. Does your calculator look like mine at all? Or is it a lot different?
What?
Huh?
What?
Oh, it's a lot different. I wish I knew what button to tell you to push, but it needs to say sine on it. And then usually to get the sine inverse, you have to push the second button and then the sine button.
Yeah. How do I know you my clean?
How do you do what?
Know you my clean.
How do you do something to your screen? Do what to your screen?
Know you.
Oh, show me your screen. Oh my goodness, I have no idea. I don't know, Connor. Sorry.
Because you did.
Right. Are you using the calculator that's on the Chromebook?
On my phone.
Yeah, on your computer. So let me show you the one that's on my computer and you can tell me if it looks like this. Why don't we do it that way? Calculator. So it's just the calculator app that's on your computer?
Yeah.
Okay. Let me see.
I.
So does it look like this?
Yeah.
Okay. So do you see this thing right here?
Yeah.
If I click on that, it gives me the different trig functions. And if I push second, okay. So I'm going to go 24 divided by 29 equals, and then I'm going to go trigonometry, second, sine. And then there's my answer way up there, 55.85.
Well, yeah.
Sure.
What number do I put?
You need 24 divided by 29.
Yeah.
And then that should have given you 0.827.
Yeah.
And now you have to go to trigonometry, and you have to do the second button,
Yeah.
and then the sine inverse button.
Yeah.
And it should have given you,
I got 5, 5, 4, 8, 5, 1, 5.
good job.
You know,
My calculator is unhappy, but you did a good job. Okay, so I'm going to stop sharing my screen. Okay, so now we're on the next problem, but before we go to it, I want to think, does 55.85 degrees make sense for this angle? Yes, it does, because this is 90, so these two angles have to add up to 90. And this one looks kind of smaller than that one, so that all makes sense to me.
I'm sorry that took me a while.
That's okay. I'm your teacher, right? I'm teaching you how to use your calculator. It's no problem. So let's look at, let's see. All of the rest of these, that's funny. Okay, we're going to do number 3. So if I start at the X, what do I call the 17?
Oh,
Good. If I start at the 90, what do I call this side?
8.
Good. So that makes this your A. So out of my SOHCAHTOA toolbox, what do I want to use?
3, 3, 8.
TOA. Good job, TOA. So we're going to go TOA, which is going to be tangent of X equals. Good work. Now, since we don't know this angle, we have to do tangent inverse of 17 over 11. So we're going to take the calculator and do 17 divided by 11.
That makes me divided by 11.
Yes, that's the decimal you need. And then you need to press second tangent.
I maybe level 4. Level
That is the exact same thing I got. Nice work.
now I know how to do it.
You are so awesome. Good job. Oh my goodness, look how squiggly my box is. Okay, does this answer make sense? 57.09 degrees. Yeah, it does make sense, doesn't it? All right, let's do one more problem. Just one more. So that's going to be this one right here. We have to label this triangle with respect to, wait a second, let me double check that. That's not the one I wanted because that will be tangent again. I want to do something different. I wanted to do this one. Sorry about that. Okay, so with respect to the x, I need to go label this side over here O. What will the 20 be?
8.
Okay, so then this is A. So out of the SOHCAHTOA toolbox, which tool do you want?
Me.
Good, CAH, right? Cosine. So now the first thing I'm putting is cosine. What do I have to write after cosine? Good. Then I need my A over H. So what is that? Good. Are you ready? You're on. It's your turn.
Nobody.
Wait, what did you just say? Do you need me to tell you the fraction?
Yeah.
Okay, the fraction is 9 divided by 20.
I didn't will.
Wait a second. I'm sorry. Hold on. I'm going to type it on my computer too. I just got behind. So it was 9 divided by 20, and then it was, we did cosine, so you need to do second cosine. Did you get an answer already?
No.
Okay. I don't want to write my answer down until you tell me because I want to know if we have the same answer.
Say cosine.
Yes. That is exactly right. Good job. That's what I got. Nice work. So, let me go ahead and press stop, okay?
Oh, yeah.